Do you want to know which side of the line to shade, or when to use a solid versus a dashed line? Today, I'll show you the fastest way to graph linear inequalities in two variables. A linear inequality in two variables represents a region of the coordinate plane, not just a line. These inequalities show all the points that satisfy a mathematical relationship. So for instance, you could have y is greater than 2x minus 3, or y is less than or equal negative x plus 4, or y is less than x over 2 plus 2. Unlike equations that produce a single line, inequalities create entire shaded regions representing infinite solution points. So as you see here, this red region would represent my solution. Here's the four-step method. First, convert to slope-intercept form. You'll want to solve for y because it makes graphing easier, and it's also easier to identify the slope and intercept clearly. Secondly, you'll need to draw the boundary line. If your inequality is less than or equal or greater than or equal, you'll use a solid line. But if your inequality is strictly less than or strictly greater than, you'll use a dashed line. Thirdly, you'll need to choose a test point. You need to pick a test point. Usually 0, 0 is the easiest unless it's on the line. And then you'll substitute x for 0 and y for 0 into your inequality. And finally, you'll be able to shade the correct region. If the test point makes the inequality true, you'll shade that side. But if it's false, you'll shade the opposite side. So let's see an example. We have y is greater than 2x minus 1. In this case, my inequality is already in slope-intercept form. It's already solved for y. So we can proceed to draw the boundary. So if I draw the line y equals 2x minus 1, it's this line right here. You can see that it crosses the y-intercept at -1. It has positive slope 2. Then we'll pick a test point. Let's say we pick the point 0, 0. And then we'll need to plug it into our inequality. So when y is 0, is that greater than 2 times 0 minus 1, which is -1? It is true. Therefore, that's the region that we'll want to shade. The region that contains the point 0, 0 is the region that will shade. And we can see that we have a dashed line because our inequality was strictly greater than y greater than 2x minus 1. So this is our solution, this region right here in red. Now, if we have y is less than or equal to -x plus 3, in this case, it's already in slope-intercept form. Then we can draw our line. So if we draw the line y equals -x plus 3, this is this red line right here. It crosses the y-intercept, it crosses the y-axis at 3, and it has negative slope -1. So this is our line, and we have a solid line because our inequality is less than or equal. So then we'll want to use a test point. So let's say once again we use the point 0, 0. When y equals 0, is that less than or equal to -0 plus 3? Yes, 0 is less than 3, so that is true. So this is the region that will be shaded, the region that contains our test point 0, 0. Now, what if my inequality has the form x plus 2y is greater than 6? So it's not in slope-intercept form. The first thing we will do is solving for y. So we can subtract x on both sides of the equation of the inequality. This will become 2y is greater than -x plus 6. And finally, to solve for y, we'll divide both sides by 2. So y is greater than negative x over 2 plus 6 over 2 is 3. So in this case, we can graph this line y equals negative x over 2 plus 3, and we'll use a dashed line because our inequality is strictly greater than. So our line is right here. We can see the y-intercept at 3. It has negative slope, negative 1/2. Now if we test the point 0, 0, plug it into our inequality. When y equals 0, is that greater than negative 0 over 2 plus 3? 0 is not greater than 3, therefore it is false. So in this case, we'll want to shade the opposite side of the test point. So not this side, but the region above the line. So this will represent our solution. If you like what you see so far, please like and subscribe to our channel. So here are some special cases. Let's say I have x is greater than or equal to 4. So we'll draw the line x equals 4, and we'll have a solid line because our inequality is greater than or equal. So in this case, the values that make this true would be any value of x that is greater or equal to 4. So x equals 5, 6, 7, 8. So we will shade the right side of x equals 4 in this case. If we have y is less than negative 2, this is a horizontal line. So if we draw a dashed line at y equals negative 2, and we have a dashed line because our inequality is strictly less than. Any value that is less than negative 2, that is negative 3, negative 4, negative 6, will be shaded. So in this case, we'll shade below the line. So now what if I have a system of inequalities? I want to graph both y is greater than x minus 2 and y is less than or equal negative 2x plus 4. So first, I'll need to draw both boundary lines with correct solid or dashed style. So for y is greater than x minus 2, I'll have a dashed line. But for y is less than or equal negative 2x plus 4, I'll have a solid line. So then, I can shade each inequality separately using test points. So let's say I'll use the point 0, 0 for my first inequality and 0, 0 for my second inequality, and I will shade the appropriate region. Finally, I'll need to find the overlap. The solution is the overlapping region where both are true. So let's see how this applies. Here I have graphed both inequalities. First, y is greater than x minus 2 is the red dashed line here. We use the dashed line because our inequality is strictly greater than. You can see the y-intercept at negative 2 and it has positive slope. So using a test point of 0, 0, when y equals 0, is that greater than 0 minus 2? Yes, 0 is greater than negative 2. Therefore, a shaded region is the region above the line, or the region that includes the point 0, 0. Now we need to do the same for a second inequality, y is less than or equal to negative 2x plus 4. We have the green solid line, and we use the solid line because the inequality is less than or equal. You can see the y-intercept at 4 and our negative slope. If we use our test point of 0, 0, when y equals 0, is that less than or equal to negative 2 times 0 plus 4? 0 is less than 4, therefore the region that needs to be shaded is the region to the left of the line, which is the region that includes the point 0, 0. So now, since we have a system of linear inequalities, a solution will be the overlap of the two regions. And we can see that right here, this region is the solution. Here are some common mistakes to avoid. First, using the wrong line type. So you need to make sure that you use a solid line if your inequality is greater than or equal or less than or equal, and a dashed line if it's strictly greater than or strictly less than. The second mistake to avoid is shading the wrong side, not using a test point, or misinterpreting the test point result. The third mistake to avoid is skipping conversion. As much as possible, you'll want to rewrite the inequality in slope-intercept form first. Using a bad test point. Using a test point that lies directly on the boundary line won't help you, so you'll want to use a test point that is not on the line. And then finally, it's confusing systems. Mixing up inequalities when graphing systems, you want to label each one clearly. Here's a quick recap. First, solve for y. You'll want to convert to slope-intercept form. Then you'll draw the line, a solid or a dashed line based on the symbol. Use a test point. Usually 0, 0 works best, but if it's on the line, you can use any other point. Then shade the region. If your test point makes your inequality true, shade the region that includes the test point. Otherwise, shade the other region. And if you have a system of linear inequalities, find where the regions intercept. That's your fast track math method. Quick, visual, accurate. Here's your challenge. Graph the system y is greater than 1/2 x minus 1 and y is less than negative x plus 4. So you'll want to answer these questions. Do I use a solid or a dashed line for each inequality? Which way do you shade each one? And what is the final overlapping region? Drop your answer in the comment. You can now graph any linear inequality and any system fast. You've mastered the 4-step method and learned how to avoid common mistakes. Thanks for watching. Hit like and subscribe. And don't forget, math success starts when you stay on the fast track.